Hello friends, in this video lecture, we will try to understand what is Huffman coding and what are the types of an example which we can solve in a Huffman coding. So Huffman coding, this is a technology which we can use for a lossless compression. We have already known what is lossy and lossless compression. So in the lossless compression, Huffman coding algorithm is frequently used, and there are many types of the Huffman coding algorithm. Depending on how to solve the example of Huffman coding, it can be classified into the multiple categories. For example, log2 based Huffman coding with r is equal to 2, that is binary, r is equal to 3, that is ternary, and r is equal to 4, that is quaternary. So in this video lecture, we will first try to understand the example with log base 2 at r is equal to 2. Now what are all these things? For that purpose, let us have a look on a theory behind Huffman coding. The first one is arrange the given symbols in a descending order of the probabilities. Symbols and probabilities are given to us in an example, and we require to first arrange that symbols with respect to their probabilities but in a descending order. This is the first step of Huffman coding algorithm. Second one is assign two symbols as 0 and 1. We have to assign two symbols from a given symbols as 0 and 1s, but who have the lowest probability. That means who are having the minimum probabilities, assign that two symbols as 0 and 1. Third one is combine that two lowest probability symbols and combine the answer, and that answer should get shift at as high as possible level. Means simply we require to do sum in this particular step. Sum of what? Sum of two lowest probabilities, and then we have to shift that two lowest probabilities at as high as possible level of your given code of probabilities. So let us have a look on example first. So the given alphabets with the probabilities are 0.2, 0.4, 0.4, 0.2, 0.2. Simply we are having 5 probabilities. These are nothing but what? Probabilities. And these are nothing but what? Symbols. For symbols S1, S2, S3, S4, S5. And the question is find Huffman code. So in the first column we have to write all symbols. Second column write all probabilities, but keep in mind probabilities must be in the descending order. So fortunately in the given example all the probabilities are in the descending order. So write down them as it is. If not, you have to arrange them with respect to that proper symbol. Next step is assign 0 and 1 for the lowest probability symbol. So as already the given probabilities are in descending order, the last two probabilities are having the lowest probabilities, and hence assign them as 0 and 1. Hence for S4 I assign it as 0, for S5 I assign it as 1. The next step was combine that two lowest probability symbol. So combine means what? Sum that two lowest probabilities. So what are the lowest probabilities? 0.2 plus 0.2. So that will be what? 0.4. And shift it at as high as possible level. As high as possible means what? I cannot directly move it to the first probability level. Why? Because the first probability answer is what? 0.8. And our sum answer is what? 0.4. So obviously 0.4 is less than 0.8. Hence I cannot shift it directly at probability number 1. Rather than that, as high as possible means after 0.8, what is the present probability? 0.4. So compare present probabilities and sum. So sum is what? 0.4. After 0.8, what is the present probability? 0.4. Now both are equal. Still, you require to shift the sum to as high as possible level. So as high as possible means what? After 0.8, I must have to shift this 0.4 over here. And because of this, 0.8 will be as it is. This is the answer of this 0.4. Hence, this 0.4 will get shifted over here. And this 0.4 will get shifted over here. So like that, we require to change the position level or level of the probabilities. After that, again do the same thing. Now in between this 0.8, 0.4, 0.4, 0.4, what are the lowest probabilities? Obviously, these last two. So that do one thing. Again, assign 0 and 1 for the lowest probability symbol as I have already assigned. Combine them, the sum of the probability will be what? 0.8, that is 0.4 plus 0.4, and shift at as high as possible level. Now the highest number of the probability is 0.8. That means what? Present probability is 0.8. This is what? Step number 2. This is our step number 1. At step number 2, the highest present probability is 0.8 and the sum is again what? 0.4 plus 0.4 means what? 0.8. So compare these two things, both are equal. Then we have to shift this at as high as possible level. So 0.4 plus 0.4, 0.8, that will be shifted here. So because of that shifting, what will happen? This 0.8 will be present over here. And this second 0.4 will be present over here. Now, the next step, we have to repeat this step again and again until and up till we are not achieving the last two lowest probability symbol. Again, what are the lowest probability? 0.8, 0.8, 0.4. In between that, 0.4 is the maximum lowest probability. After that, both are equal. So you can select as per the order 0.4 plus 0.8. Now, in the step number 3, what is the present highest probability? That is what? 0.8. And what is the sum of the last two lowest probability? 0.4 plus 0.8. That is what? 1.2. So sum is higher. So shift the sum. That is nothing but what? 1.2. And this 0.8 will come over here. And now we are able to achieve the two lowest probabilities. That is what? 0 and 1. And here we have to stop. Why? Because here we have considered it as a binary Huffman coding technology. Binary means what? 2. So whenever we are getting the two lowest probability or the two last symbol having some probability, then we require to stop while solving the answer. And then we require to write down the code for all these things. So as per the step, first of all write down symbol, second write down the probability in the descending orders and with respect to their symbols. Third one is combine the two lowest probabilities and shift it at as high as possible level and do these steps again and again until and up till you are not getting the two last probabilities in your given tree. So like that we have to complete the one part of our example. So with the help of this solved example, we have to write down the output. And this is nothing but what? Our required Huffman code. So how to write down this output? See, write down first the given symbols. After that, write down the code for them. How to calculate the code for them? Code for S1, if I want to verify the path for S1 from this first step to this the last step, then how to observe or recognize the codes? S1, this is the first pointed, that pointed move over here, that move over here. Hence, I will write down the answer 0 After that, again this step and these steps. That means what? The first 0 I will get over here. The second 0 I will get over here. So answer will be 0, 0. Again I will try to explain. 0.8 is the probability of S1. Try to find out the path for that particular probability. This 0.8 first move over here. Here the value of 0.8 is what? 0. Why? Because we have assigned it as a lowest probability and the value of the lowest probability was 0. After that it moved towards what? 1.2. Value of 1.2 assigned in a binary form is what? 0. So the answer is 0, 0. Similarly, try to find out some answer for S2. Probability of S2 is what? 0.4. Try to find out how that 0.4 will shift. 0.4 gets shifted over here, 0.4. The answer for this is what? 0. So write down first 0. After this particular 0.4 was moved by combining it into the sum, and that answer is what? 0.8. To 0.8, nothing was assigned in the next step. So find out where it moves. This 0.8 moves over last step, and here that answer is what? 1. So answer is 1. So final answer is 1, 0 for S2. Like that for S3. Probability of S3 is what? 0.4. 0.4 was get shifted in the first step over here. Here the value of 0.4 is what? Answer 1. Again the combined answer shifted over here. Here the answer is 0.8 to whom no any probability or no any binary value was assigned. So that moves at next step, that means at last step at here, and the answer is 1. So the final answer is what? 1, 1. Next one is S4. To S1, what is the probability? 0.2. 2.2. What was assigned in the first step? 0. Why? Because that is the lowest probability in step number 1 itself. So here you are getting some answer that is 0. This combined answer gets shifted to the column 2, that is to the 0.4. At this there is nothing which is represented with the help of binary symbol for this 0.4. After that this 0.4 gets shifted over here, where the value of the 0.4 is what? 1. Binary value of 0.4 is 1. So 1 will be the next level answer. These 0.4 and 0.8 get combined and its answer is nothing but 1.2, and that value in the binary representation is 0. So the total answer is 0, 1, 0 for the S4. Similarly, try to find out the final answer for S5. 0.2 is the lowest probability with assigned value 1. So the answer is what? 1. The first answer will be 1. This 0.2 is get combined in the step number 1 itself, and the answer is 0.4, which is moved in the next column. That 0.4 having no any binary assigned value, that is already shifted as it is in the next level, where it has some value, that is nothing but what? 1. So the next answer is 1, and this is now combined, get combined and shifted as 1.2, who is having the binary assigned value 0. The total answer is 0, 1, 1 for S5. In this way we require to find out the path for the code, and then we will write down the codes. So this is nothing but the codes, and this is nothing but length of the code. So how to calculate the length? Simply how many bits are present in the codes, that is nothing but the length. So here I will try to change something. This is nothing but 3, so 2 plus 1, and this is again the 3, 2 plus 1. So in this way we can calculate codes as well as length for all the symbols and assign probabilities to that particular symbols. Why to calculate these two things? Because there are few factors. With the help of this output, we require to calculate some factors on Huffman coding. So what are that we will see now. So factors can be calculated from the Huffman coding are as follows. First one is H. It is known as entropy. So formula for H is summation of I to 1 Pi log 2 1 by Pi, or inverse of probability. Pi means probability. Probability of I means what? I from 1 to n. that is what? The respective symbol number probability. And log base 2, here we require to solve the example with the help of the log base 2. This is the technique behind the Huffman coding theory with log base 2 example. And here we can calculate the entropy which having the unit bits per symbol. Second one is efficiency. Efficiency is H divided by L log to the base R. Here R is 2. Why? Because we are interested to calculate what? Binary example. So R is 2. H is nothing but the entropy which is already calculated in the previous step. And L we have to calculate, that is nothing but average code length. So how to calculate N? L is nothing but Pi into Ni. So what is Ni? Ni is nothing but code length. So Pi is probability, Ni is code length. So in this way we can calculate the average length. Again that will having the same units, bits per symbol. And last one is variance. To calculate the variance we are required to use this particular symbol, sigma square. And its formula will be Pi probability in bracket Ni code word length minus L average code length square raised to 2 means it's square, and in this way we can calculate variance. So I think let us have a look how to calculate it so that you can easily understand the steps. So the example is alphabet with probabilities which we have already calculated 0.8, 0.4, 0.4, 0.2, 0.2. For the all the symbols from S1 to S5 we have to calculate for Huffman code and the factors. So we have already calculated the Huffman code. Now we are interested to calculate the factors effects on the Huffman code. So H first is nothing but entropy. How to calculate it? H is equal to probability log to the base probability. So for the first symbol S1, what is the value of probability? 0.8. So 0.8 log to the base 2 1 divided by 0.8. Simply this will be the answer for the first symbol. Plus then the next two probabilities are same 0.4, 0.4. So what I can do? 2 into 0.4 log to the base 2 1 divided by 0.4. Again plus 2 into last two probabilities are same. So 0.2 log to the base 2 1 divided by 0.2. So first try to calculate 1 divided by 0.8. That answer is 1.25. So here I will get the answer log to the base 2 1.25. Now on your calculator, we all know that we are not able to directly calculate log to the base 2. Why? Because our engineering calcs are more familiar with log to the base 10. So how to solve this? That is the main important factor behind this particular example. So log 2 convert into log base to the 10. So log base to the 10, your answer 1.25 divided by log to the base 10 2. So this answer you can easily calculate on your calculator and write down that particular answer over here. Means log 1.25 divided by log 2 simply, and that answer will come over here. Similarly 2 into 0.4 log base 2 1 divided by 0.4. The answer for 1 divided by 0.4 is 2.5. So what you will do? Simply log 2.5 divided by log 2. Find out that answer, you can insert it. Plus 2 into 0.2 log 1 divided by 0.2. The answer is 5 divided by log 2. Keep in mind this log 2.5 having base 10. So all logs having base 10. Why? Because our calc is familiar with this base 10 log. And in this way you can calculate the answer, and the final answer for the entropy is 3.28. You can verify this answer, and its unit is bits per symbol. So in this way we can calculate the entropy. After that we can calculate the length, and so that we can calculate the efficiency. So the next step is calculation of length. Now the next point is find out the length. Length is nothing but what? Probability into code length. So this is nothing but Ni. So what is the probability for first symbol? That is 0.8. So 0.8 into codes which we have find, that length, that is what? 2. So 0.8 into 2 plus 2 into 0.4 into 2. So now we will calculate the length. Length is nothing but summation I is equal to 1 to n. So maximum value of n is 5 in our example. Pi into Ni. So Pi is the probability. So how to calculate it? For S1 the probability is 0.8. So 0.8 into code which we have find out, that is 00 for S1, and its length is what? 2 bits. 00 means 2. So 2 bits, so that calculate it or multiply it 0.8 into 2. So this is the answer for symbol S1. Similarly, for the next two symbols, probabilities are same. So you can say 2 into in bracket 0.4 into, for the next two symbol, again the code word which we have find, it is same, that is 2. So 0.4 into 2. Plus for the last two symbols which are having the probability 0.2 and 0.2, the code word length was 3. So 0.2 is nothing but the probability into code word length is 3. So 3, and it repeats twice in our whole diagram. So I can multiply it by 2. So like that you can calculate the answer. 1.6 plus 1.6 plus 1.2, that is nothing but 4.4 bits per symbol. Again the unit for the entropy and for the length is same. So the unit is bits per symbol. So after calculation of H and L, we are able to calculate the efficiency. So how to calculate the efficiency? E is equal to H divided by L log to the base 2R. So R, we all know that for this particular example, as it comes under the binary, R is equal to 2. So 3.28 divided by L 4.4 log to the base, convert it into 10. 10 of what? Answer. Answer is what? R is 2. So 2 divided by log to the base 10 of 2. So you can easily calculate this. Log of 2 by log of 2 is what? 1. So 3.28 divided by 4.4 will be your simply the answer for the efficiency, and efficiency you require to write in the form of percent. So simply you can calculate 3.28 divided by 4.4 and convert it into the form of percent. This is the unit of efficiency. The last point to be calculated with the help of this example is nothing but variance. So how to calculate the variance? Its formula is Pi in bracket Ni minus L square. So there are 5 symbols, but 2 symbols twice having the same probability, 0.4 and 0.2. So as usual we will try to calculate it sigma square. The first one is Pi. Pi means what? Probability. Probability of first symbol is 0.8 in bracket Ni, code word length 2 minus L. L we have already calculated, 4.4 whole square. Now here try to understand 2 minus 4.4, you may get the obviously negative answer, but the square of any negative value will be again positive. So no need to worry about it. Finally your variance will be in terms of the positive number at anyhow. Plus 2 in bracket again the probability. Why I wrote here 2? Because 2 symbols having the same probability as well as same code word. So 0.4 in bracket 2 minus 4.4. 2 is nothing but what? Code word length minus 4.4 is L square. Again there will be some value, but that will be positive. Plus again the last two values, 0.2 probability. So 2 into in bracket 0.2 in bracket. Now the code word length for the last two symbols S4 and S5 was 3. So this is the answer, 3 minus 4.4 bracket square. So in this way you can easily calculate this answer, and you can write down some value for the variance. So by using the Huffman code algorithm, the first type of the example which is completely based on the binary technique, so that we can calculate in terms of the code encoded output, in terms of the code word length, and then we can calculate the factors affect on the Huffman code that are nothing but entropy, length, efficiency and variance. Thank you so much for watching this video lecture. Stay tuned with Ekeeda. Subscribe our channel.